What's up, everyone? This is LeetCode 53, maximum subarray. So we've done this problem in Python, now we're doing C++. Yeah. So also, this was the first medium problem that we've encountered in the Grind 75 list, so congrats if you've been following along, because we are done with easy problems. Not that it means much, honestly. Some easy problems I feel like, should be classified mediums, and some mediums should be easy, but still, it's like a morale boost, I guess. Anyways, so we're given an integer array nums, right? And we have to find the subarray with the largest sum and return its sum. And a subarray is a contiguous, non-empty sequence of elements within an array, right? So this is a subarray, this is a subarray, this is a subarray, this is a subarray, etc. And so how do we find the maximum sum, right? Well, we have to find the largest sum, right? So how do we find the maximum, the largest sum here with given we have a bunch of subarrays we can choose from, right? And the idea is we're going to keep track of two variables, right? One is a current sum as we traverse this array, and another is the maximum sum, which is, you know, keeping track of the maximum sum we've seen so far. Okay, and the idea is, like, let's say we go to this -2. Okay, that's the max sum we've seen so far, -2. Well, if we go to here, our max sum we've seen so far is actually -1. Or the max sum could just be 1, which is obviously bigger than both of those other ones, right? Well, let's say we look at something like this, right? This would be 5, right? The sum from here, from all these. And so as you can see, right, our sum is going to change depending on what subarray we're looking at. So that's why we need to keep track. We need two variables. One is basically tracking the sum of whatever subarray we're looking at, and another is basically just keeping track of the maximum sum we've seen so far. Okay, that's why we need two variables. Okay, so let's create a current sum, right, and the maximum sum. And for the maximum sum, we're basically going to set it equal to -infinity, right? We're going to do this. Now, if you want also, I mean, I don't know, some interviews maybe don't let you use built-in, like, things like this, but you can also just set max sum to the first element in the array, because there'll always be at least one element in the array. Doesn't really matter. I just prefer this. I find it more consistent, I guess, rather than trying to, I mean, it doesn't really matter anyways. We're setting max sum to -infinity, basically, okay? Now, we obviously need to go through the array, like I said. So we're going to say I ++. Okay. Now, the issue here is, first of all, as we're traversing, we're going to add the current element that we're on to the current sum. So that'd be nums of I. Okay. And then we need to take the maximum. We need to find basically the maximum between the current sum and the max sum. Okay. Because let's say we are looking at a subarray, and the sum of that subarray is larger than the current max sum that we have already stored, then we want to update the max sum at that point, right? So for example, let's go through example 1. Okay, so -2. Right? So here we would add nums of I, which would be -2, to current sum. So current sum would be -2. Now let's compare the max between -infinity and -2. -2 is obviously bigger than -infinity. So -2 would be our new max sum. Okay, we can move to -2 and 1, which would be -1. Well, -1 is greater than -2, so we could update our max sum to -1. But the issue here is 1 is bigger than -1 also, right? So how do we know whether to take this or this? Like, how do we logically take care of that problem between choosing those two? The thing we would do is, if we have a current sum that is negative, we can just set it to 0, right? Because why would we ever care about a current sum that is negative, when if we encounter a number that's positive, that'll naturally be bigger than any subarray that has a negative sum, right? So we can just do that by doing basically if current sum is less than 0, right? Then we can just set current sum to 0. Okay? And that'll handle that issue for us, right? So let's go through example 1 together, okay? So -2, that would be, and matter of fact, let me just keep track of these in a variable. Max sum, another one called current sum. Okay, -2, right? Okay. We add that, right? -2 to our current sum. Okay. We have negative infinity here, right? Because we set that up here. Negative infinity, and compare that to -2. -2 is obviously bigger, so update max sum. Move on. Okay. Current sum is -2, so if it's less than 0, so let's set current sum to 0 and move on. Okay. Add 1 to the current sum. This is 0. Now we add 1. Is 1, compare -2 and 1. 1 is bigger, obviously, so that would be our new max sum. We add -3. That'd give us this subarray would give us -2. That's not bigger than the maximum of 1, so we can just skip that. And again, it's negative, right? So set current sum to 0. And move on again. Okay, we have 4. Right, we add 4 to current sum. Okay, 4 is actually bigger than 1, so 4 would be our new max sum. Okay, do this. That would be 3. 3 is not bigger than the maximum of 4, so move on. This is 5. 5, right, would be bigger than 4, so we update our max sum, right, for this subarray here. We add another one. We add this 1. Okay, now our max sum is 6. Or our current sum would be 6. And we would have to update our max sum because 6 is greater than 5, right, with this subarray here. And then we basically keep going. We have 1, then we have 5. And again, none of those are bigger than... I'm not updating this as I go, but we have 1 and then 5. None of those are bigger than the maximum of 6. So we basically would exit this program and return 6 because that's our max sum. And that's what we should expect, right? And again, we have an explanation here, right? The largest sum is 6 for this subarray, which is what we were just looking at here, right? Up here. Okay. I'm not going to go over example 2. It's kind of pointless, just one element. Now let's go example 3, okay? 5. That's our current sum. Compare negative infinity with 5. 5 is bigger than negative infinity, so that's our new max sum. We add 4, so we have 9. Okay. Update our max sum, right? Because 9 is bigger than 5. Okay, we add -1, which is 8. Right? Now we add 7, right, to 8, which gives us 15. And again, 15 is greater than 9, so we update our max sum. Okay. Then we add we add 8, right? This is our new subarray we're looking at. We add 8 to current sum. That gives us 23, right? And again, 23, when we're right here, 23 is bigger than 15, so update our max sum. And yeah, basically this subarray, which is just the entire array, our input array, is basically the largest sum. So pretty interesting, right? I always like to do this, just give random edge cases that I can think of, just so we can think it through, right? So what if we have an input like this, -5, -2, -7, right? Okay, let's add -5 to our current sum. Well, -5 is greater than negative infinity, so that would be our new max sum, right? Makes sense. Now our current sum is less than 0, so set current sum to 0. Move on. Get this -2. Okay, add that to our current sum. Well, -2 is greater than -5. Update our max sum. -2 is less than 0, so set current sum to 0. Move on to -7. Okay. -7 greater than -2. No, it's not. So we already went through all these, and our max sum that we found is -2, which makes sense, right? We don't have any positive numbers, We don't have any positive numbers for this input, so basically we take the negative number that's closest to basically 0. So yeah, that is a problem. Hopefully by going through these examples with you after giving the code, you kind of follow along with what we're doing. And this specific algorithm is Kadane's algorithm, right? You really want to get technical and look into it, into the person who found this algorithm or discovered it. But yeah, this is our first medium problem in the grind 75 list. So, you know, upwards and onwards. These problems will definitely get a lot more complicated. I think this is a good introductory medium problem, but there's a few medium problems that get a little bit complicated, but we'll get to that when we get to that. Anyways, I hope this helped. Well, I should submit also. I hope this helped, and I will see you in the next one. Peace.